We're continuing our discussion on data engineering, particularly the transform part of extraction, transform, and load. So we cleaned the data in our previous video. Now we want to code it, and then we want to manipulate it. So we are moving from Excel, where it was quicker to clean it using the filter button, and we are now going to move into Python in order to code and manipulate. So we're continuing our discussion, our survey from collective bargaining that we have here. And so we're going to use the results of that data set to code. So what we mean by coding is we're going to convert our nominal data, where we have text in categories, and we're going to convert it into numbers to make it easier. So for example, you see here Q1 of 5. And so if we go back in time to the question, Q1, what should be the top priority for the next round of bargaining? We're going to take these words here, improve benefits, and we're going to code it as a 1. Improve working conditions, coded as a 2. Job security, coded as a 3. By doing this, we can do some of the analysis quicker because we can simply have it look at how many ones there are. Depending on what data visualization tool you are using, having it coded as 1, 2, 3, 4, 5 works better. And for others, you can leave it as text as long as it is the same wording for each. So everyone who chose improved benefits has the same words, improved benefits, same formatting, capitalization, spaces, all that stuff. You can simply do data visualization and analysis with that. So whether or not to code, it depends on what type of analysis and visualizations you're going to do. What I often do is I often just code the whole thing, because then I can just do loops of analysis to streamline it, and then later I figure out which analysis is appropriate based on the data. So you choose. I'll show you how to code it, and then you can code part of it, you can code all of it, or you can wait until you get to the type of analysis or visualization you want to do to decide if you need to code it. So for that reason, because you might decide to do it later, we're going to show you how to do the coding in Python as opposed to in Excel. If you do the coding in Excel, what you would do is you would use, I've shown it here under manipulate, but you would use the same if statements in Excel to code as well. So basically what you would write is you would write here, if this column says improve benefits, then make it a 1. Otherwise, if it says working conditions, make it a 2. Otherwise, if it says job security, make it a 3. So it's a lot of nested ifs in Excel to make it work. This can also be a little tricky because if you screw it up with the wrong parentheses, commas in the wrong spot, it doesn't work right. So it is easier to code in Python than, say, to do it in Excel. So I'll just show you how to do it in Excel. All right, so here's what we want to code. We want to take question 1, which is nominal, it's categories, and we want to have improved benefits be labeled as 1, working conditions as 2, job security 3, relationship 4, increased pay is 5. There's an other option, so we want to separate that open-ended question out to be a separate question. And then we want to create an other option labeled number 6, so we know that they chose something besides 1 through 5. For the nominal question number 2, whether they're part-time or full-time, we'd say 1 for part-time, 2 for full-time. If possible, when coding, stay away from zeros, because there's a difference between an empty cell where you cleaned out the number that was there, or they didn't answer the question, versus you labeled it 0 because your code has something that 0 has meaning. So stay away from zeros. 1, 2, 3, 4, 5s. If it's ordinal data, then of course you got to pick an end. Is bad number 1 and good the higher number, or is it the other way around? And then what you'll do when you're coding, even though part-time and full-time are 1 and 2, in that case, it doesn't mean that 2 is better than 1 or even more than 1. It's simply the number you've attached to it. So it's very important to know what the appropriate measurement scale is if you're going to use coded data. So let's code. So what we're going to be doing is we're going to be working through this data prep workbook in Python. So just a couple things to get you started. So first, All of the workbooks can be found at drstephpowers.github.io. We are doing data prep under appendix here. You can find here on the right, when you go in, some of the Excel files. You'll want to download those and put them into your Google Drive. If you are working through this material as part of your school's learning management system, you will find the Excel files inside, say, Blackboard for you. What you will need to do, though, is you will need to open this in Colab. You will need to log into your Google Drive and save a copy. So I recommend you create a folder, save all this stuff in the same folder, and then you dump your Excel or CSV files in that same location. So I'm just going to go to the copy that I have open. Because we're going to start loading things from spreadsheets, we need to pull them from our Google Drive. So we are going to import pandas as PD. You need this in order to read Excel files or CSV files. The next thing we want to do is we want to mount our Google Drive. So this code as written, if you hit this, what it will do is ask you if it can have access to your Google Drive. Nobody else has access to your Google Drive. It's only you, for purposes of pulling that data set when you run code. So here I'm saying give it access so that it can pull the files. So then what I need in my Google Drive is I need to make sure I have dropped in those Excel files or CSV files. And we're using this approach because, again, if you are pulling your data from, say, Google Cloud, you could export that CSV into your Google Drive. So you might as well get used to pulling things from your own Google Drive. So then once you've mounted your Google Drive for your access, then what you're going to do is read that Excel file, which means you need to say where it came from. So we're going to be working through an Excel file called Bargain Clean. So this is a version of that survey, that bargaining survey, already cleaned up. And so what you'll want to do, whether you're pulling Bargain Clean from GitHub, right? So we just back up here. Whether you're pulling Bargain Clean right here from GitHub, or whether you're pulling it from your learning management system like Blackboard, take the Excel file and drop it into a folder in your Google Drive. See, mine is in My Drive, and then I have a folder called BIBA Handbook, and then I have Chapter 4. And so I need to know the name of the file, Bargain Clean, and the location. So for me, when I run it, it is going to be My Drive, that's true for everybody, / the name of my folder, BIBA Handbook / Chapter 4, so that's the folder inside the folder, and then the name of the file. So you'll want to do the same thing. This part is going to be exactly the same. Then it's going to be a folder inside your main drive, and if you have a second folder, then put that, and then the name of the file. So if you just stick it directly into your drive, you won't have this section here. But you might want to create a folder for all these videos if you're working through a bunch of them. All right, so let's dump it in. Let's import it. And then I always like to do, first you name it. So we'll name it DataFrame DF. And we'll do df.head. This allows us to then see the first couple rows. If you don't specify anything, the default is 5 rows. And alternatively, you could specify a different number. So you want to see the first 6 rows, then you put 6. See, there's 6 rows. Remember, counting in Python starts at 0. So even though the index is 5, there is a 0 row here. So it is 6. All right, so I've entered in my data. It should look very similar to what we looked at in Excel, although it's cleaned up, which means that the part-time that we saw before, where someone had filled out question 3 and 4, even though they were part-time, has been removed. When you dump in your Excel file, any empty cells get this label NaN, not applicable, so that it distinguishes from a 0. So we know it's empty as opposed to it has a value of 0. All right, so we've imported our data. If you are importing instead a CSV file, The only difference would be is that it would be pd.read_CSV. It's still going to be the same path you had before, which for me, it's going to be content, drive, my drive. That's true for everybody. And then whatever folders and the name of your file. So the only difference is that if we are doing a CSV file, we would do pd.read_CSV. And this would be CSV. Okay, so if you're importing from a CSV file, this is how it would look instead. We just change this part to CSV and that part to CSV. Okay, now we want to code and prepare our data for analysis. So the first step that we're going to do is we are going to separate any open options from the list. So if you recall, if I go back to question 1, question 1 had a write-in option. So we had 1 through 5, and then we had an other. So we want to separate this out to a second variable that is just the write-in responses. Anyone who wrote something in, we want to classify that other as a category. All right, so how do we do this? Well, we're going to do it not with question 1, but we're going to do it with question 4. So let's look at question 4. What healthcare benefits should be prioritized? So you see the other write-in here. And then we have, what do we have? 6 options here. So let's take a look at how to do this. So this DF, hard brackets Q4A, means that we are looking at just column Q4A. Well, Q4A doesn't exist yet. So we're going to create a column called Q4A. And we're going to start off by creating it by simply just taking question 4. So df Q4A creates a new variable in that table df from question 4. And then if we do df.head, again, you can make it however many rows you want, you'll see at the very end here, we have a new column called 4A that matches question 4. So first thing we do, duplicate question 4. Now that we've duplicated question 4, let's use the replace command that you've seen already. And in this column that we'll call 4A, we're going to replace, anytime it sees wellness account, we're going to replace it with a 1. And anytime we see health spending account, we're going to replace it with a 2. Anytime we see massage, we're going to replace it with a 3, chiropractic care a 4, dental a 5, drug coverage a 6. Okay? Then we're going to do in place equals true because we're just going to have it take out the words and put in the numbers. So we're doing our label, our coding for the parts that are part of the list they could pick from. We do replace as the command. We have the curly brackets here because this is a dictionary. It has both the variable and the value that we're looking at, and we're replacing all of those. So let's run that. So when we do this, we can see for the first 4, question 4 in its original view is additional funding for counseling, drug coverage, non-response, non-response. Okay, it's because the part-timers don't have response. All right, so now if we go over, you can see that the one that was labeled drug coverage is now labeled a 6. The one that was additional funding for counseling was a write-in response. So it has not been relabeled a number. It's sitting right here. And the ones that were empty before are still empty. So because this one is not just about coding the choices, we have an extra step here to deal with the write-in response. So how do we deal with the write-in response? Well, what we're going to do is we're going to use NumPy. So, and NumPy is a package that allows us to manipulate things, lists, strings, all that stuff. So we're going to import NumPy as NP. We always need to import the appropriate packages to run. So we'll do that. And then we're going to use this command here where we are going to have it say, here's the list of things that I don't want you to change. So list not change is a name. And here we have our list. Now, in column 4A, we don't want it to mess with the ones that have been relabeled 1, 2, 3, 4, 5, 6, or that are NaN. So the NumPy, you see here the NP, this NaN says don't touch the ones that are like this one you see here, where it's NaN. Okay? Then what we're going to do is say, okay, take the table and locate, and we're looking for question 4A, and what we want to do is we have the list not change. So this squiggle here, right here, is that we want to go into 4A, and we want to find the ones that are not in the list not change. So anything that is not in the list not change, like the write-in response that we saw up here, additional funding for counselor, we want to label 7. So locate anything in 4A that is not in this list. So not, and then in this list, then we're going to label 7. So if we run this, what you'll see is that the first row is now a 7. That write-in response is a 7. And it hasn't changed the 6, and it hasn't changed the NaNs, which means we have now created a new column that has coded question number 4 to be 1, 2, 3, 4, 5, 6. If they wrote other, it's now a 7. And that's now question 4A in our database. Now we want to take the rest of 4, all those write-in responses that we just recoded as 7, and we want to move them over to their own variable. So let's look at how we would do this. What we want to do is say, okay, let's locate in our data frame, in our table we call DF, locate those that are Q4A that are equal to, remember 2 equal signs means they're the same. So if there's a 7 in Q4A, then we're going to create a Q4B, and that Q4B is going to be equal to whatever was in the original Q4. So locate in the table where the data frame table here, DF is the name of our table, in column Q4A, where it is equal to 7. Then for our new column Q4B, we don't have to create it to start with, we just say here's the new name of it. Then pull Q4. So if we run this, what we see is our Q4A was 7, it writes in that response. For 6, it leaves it empty. For the empties, it leaves it empty. So it's only populating Q4B with the information that was in Q4, the original entry, if it was a write-in response. So in just a couple lines of code, you have recoded Q4 to both be numbers, to number the others, and to create a variable that is the write-in responses. We can continue our coding where we don't have to separate out the other for questions like Q2. So in Q2, the answers could be part-time or full-time. So all we have to do here is say, go to our table DF and column Q2, whatever the column is named, and replace part-time with 1, full-time with 2. And if we do in place equals true, then it is putting it right on top. So when we run this, we're not creating another variable, another column. We're simply replacing the part-time, full-time with numbers. Okay, so practice. Can you do what we did for Q1? Just like we did with Q4 with the other, can you recode Q1 to have all the choice responses and then label the other and create a new variable for the write-in responses? So create a code that improved benefits is 1, improved working conditions is 2, job security is 3, relationship between union and company is 4, increasing pay is 5, and if they chose other, we want to make it 6, and then create a Q1B that is the write-in responses. So pause the video and see if you can code question 1. All right, it's going to be the exact same procedure we just did. So we want to just follow that same routine. So I'm just going to go up here and we can just look at. We can look at question 1. We're going to create a 1A. And that 1A is going to look just like question 1. So we're just going to make them identical in our system. Here's 1 untouched. Here's 1A now over here with all of our words. And we're following that same process. So what we're going to do then is our next step is going to be to replace the number or replace the words with numbers. So you can simply copy the code that you had before. The difference here is that we are dealing with 1A, and the words that we're using here are improved benefits, increasing pay. And so remember, it's a 2-step process. First, we start with the parts that are the choices. So we're going to improve benefits. 1, improve working conditions. 2, job security. 3, relationship between union. 4, increase pay. 5, and in place equals true, and then show us the table. So notice Q1A is now numbers for at least the first couple rows, so it has relabeled those choices there. Then we want to do just like we did before, which is we want to create that grouping that is not part of the list. So the easiest way to do that is to do a list not change. Add my code here. Now we don't, if we've already imported NumPy as NP previously, we don't have to do it again. In this case, there are only 5 choices, right? 1, 2, 3, 4, 5. And in which case what we're going to do is make any of those that are not in 1A, that are 1, 2, 3, 4, 5, or NaN, we're going to make them number 6. And then we have it show it to us. Okay, issue here, I forgot a comma, so I need to fix that. And I'm just going to add a little bit more. Here, I'm going to add in, let's just see a couple more rows. I don't think question 1 had any writing responses, so we might see nothing. All right, so 1A, more numbers. Okay. Now we do want to create 1B just in case in our data set there are some write-in responses and we're not seeing them. So what we'll do is we'll go up to our code here. And we're going to then add a line of code. And this line of code here is going to say, well, if Q1A equals 6, because that's the other classification, then we're going to create Q1B. And Q1B is going to match whatever's in Q1. So pull that. And in this case, your Q1Bs are empty because Q1s were all from the list, at least for the first couple in the thing. All right, before we end this, try a couple. These don't have others attached to them, but simply recode question 5, question 7, question 22, and question 23. So pause the video and do those codes. These are simple if we're just relabeling. All you have to do is trade out, right? Yes is 1, no is 2. And in this case, comma, I don't know. If what you write in doesn't match exactly the way that it is capitalized or spaced, then it's not going to replace it. So just be aware that if you have a typo, when you look at your data, it won't match. So we can do this here, question 5, and you can see question 5 has been replaced with 1, 2s, and 3s, so obviously our formatting was fine. Okay, we can repeat this. It's the exact same line of code if you are coding the rest of your data set. All we're doing now is replacing question 7, and then the key is what should the words be? In this case, it's yes, no, I don't know, so we can just use the exact same code. All we did was change out for Q7. And now we can see here Q7s. And question, just double check and make sure that's right. So the other thing is to make sure as we look at our survey, I'll do that, just move to the next slide. Question 7, yes, no, I don't know, right? So we're always referring back to that survey to make sure that it matches. All right, 22, yes, no, prefer not to answer. 23, north, south, east. So let's do those real quick here. Same code. Nice copy paste choices. And yes, no, and this one says prefer not to answer. And run it. Of course, you notice I just did that to question 7, and it didn't change anything because the I don't knows were already 3s. We need to make sure we do that to question 22, not to question 7. So just fix question 7 here. Question 22. Yes, no, prefer not to answer. Question 2 we can see now, or 22 is now coded as well. Last one, question 23. And here this is north, south, east. And run it. So if we don't need to separate and create multiple variables, you can see how we're going through the list and all the words are disappearing as we are relabeling. You will notice that some of these were write-in, open-ended answers, and so we'll have to deal with those separately. So later we can pull out and create 2 tables, one of the coded responses only and one of the qualitative text. So we're continuing to transform as we prepare our data for our analysis.